Deep Learning SDK. So what we have done here is we have taken, we have gone to our website, which is now, the tech preview is still available. It's currently available, just available on Wednesday. And we basically have downloaded from the Windows machine, or it could be a Mac machine, or you could do a Linux itself.
Yep.
It's fine.
Yep.
It doesn't make a difference, but basically you've downloaded a wizard. I don't have a screenshot right now of the wizard, but and basically when I have taken that wizard, I basically have specified the IP address of the server that I'm going to want to run the deep learning on.
Okay.
You really want to do deep learning on Xeon's servers. We only support Linux. It's technically what everyone seems to use anyway. So we basically make it very easy to get basically on that server. We load then a tool that I will show you. Then a Intel Cafe. So Cafe that has been optimized for Intel, so therefore includes the MKL library and things that are needed in order to run deep learning on that server. Okay, so this is the IP address of the server. I'm using Chrome, as you can see. We just because people may not want to share their data versus other people that are using this, we do have a login. We're not doing anything right now in this demo, but basically I am now through my browser accessing the UI tool for the deep learning, right? So setup is actually a big issue with people who are, especially people who are using Cafe. It takes a really long time, and we are really trying to help simplify. So the whole one thing of Deep Learning SDK is to democratize deep learning, right? So make it accessible to more people. And in this case, we're really focusing on kind of the people getting started, which is the large majority of people. They may be experts in machine learning, but they may not know deep learning very well, right?
Okay.
And so this idea here is that you can really quickly, as long as you have that server available, get it up and running. We use Docker containers to have it be installed really easily. That's our promise. As I said, we just released it, so we'll see feedback on whether our promise is there, but that is the version of it. All right, so now you have your tool here, and as I mentioned, it's 3 steps here. You want to first of all upload your data. So in the future, we're going to supply some samples and stuff to help you here, but for this first release, we haven't. But basically, all you would do is you browse for your data set. Now, I'm looking, it's opening my computer, right? This is my default folder on my computer. I unfortunately don't have a great data set available at this moment, so I'm not going to actually upload. Plus, it would take a lot of time. But basically, what it would be is uploading a compressed file of a folder that basically says, okay, this, for example, let's do amended handwritten digits. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is my example here. So I would have a folder of 0 and have a bunch of images for 0, folder of 1, a bunch of images for 1, things like that. Okay? So I would upload the file here, and you can see here this has already been uploaded in the past, and I'm going to be using this train.rar folder. Set of images. Okay. So now I have a set of images here that I'm going to want to train my model with. So I create a new data set here, and of these, I think this one has 60,000 images. I need to say how many of them I'm going to do towards training, and how many of them I'm going to leave for validation. So the training means that those are the images, those are the ground truth saying these are the images that look like zeros, they're zeros, but I want to leave some so that when we want to test the model for accuracy, we do a new model, we do a new image and say, oh, it's a 0, is that really a 0, should have been a 0 or not, right?
That's the scoring, right?
It is, but this is all training the model right now, and you want to validate your model works before you want to
start scoring.
Really do the full scoring for inference. Okay. Now, some things I have to do from here, but basically, at the end of the day, I can. Really quickly, you can see exactly how many of images of each of them that you have as part of your training set really quickly, right? Now, once you have a data set now, you're going to run your model. So when you run your model, as I mentioned, you want to select what data set you want to use. This is the name of the data set I just was pointing at before. next you want to select your topology. Now this initial one is only using Intel Cafe. As I mentioned, we are expanding to other frameworks in the future, but right now it's just Intel Cafe. And we've only right now done it for LaNet, AlexNet, and GoogleNet. Wow, these are helpful buttons. We should probably improve that.
What is it? It's AlexNet.
Just repeat.
Okay, now that's it. But as you can see, LaNet is just a 28 by 28. The image size of that topology is really, really small. That's what it demands. And that's one of the reasons why it's really quick and it can be used very quickly to do some prototyping. Getting understanding, because at the end of the day, so yes, let's say I select LaNet for right now. This is some more data transformation, as I mentioned, but then you get these hyperparameters, and these are the parameters that are really the heart, soul of your model. And what we do is actually based on the information you give us so far, we actually default these hyperparameters, and we actually have data scientists on our team that are trying to figure out what is the best parameters to put here. So we default to certain values, and I'm not going to at all be able to explain exactly what each one of them are. Maybe this is a little better, but if you're a data scientist or someone who's doing this, you would know what this is. But you can do the default, you can override it, and the great thing about it is you can kick it off with these set of parameters, quickly copy it, and then kick off another one with tweaks to those parameters. And that way we could do multiple models simultaneously. Obviously, resource constraints could be an issue, but get things going quickly so that multiple iterations, so when you need to come back to it, you can see how it's performing. So once I would kick it off, which I didn't, I'm not going to do it for right now. Wait, let's do this one.
So if you had a whole network of Xeon Phis, for instance, you could run different experiments on each one of them individually simultaneously.
Exactly, exactly. And so, and what you'll get as it's running, and I didn't bother to kick it off here, but you would get real time a graph of how you're doing. How you're doing is your train loss, your learning rate. Basically, at the end of the day, how you're doing on your accuracy. It also will tell you how much time is left. Which seems like it's very simple, but if you're using Cafe and it's command line, you actually have to create scripts to actually create a graph that would tell you this information, right? And we really quickly just have it at your fingertips. So anyway, so it's basically doing some real-time graphs, and then at the end of the day, it's going to give you some analysis. So basically, out of my validation set, all the ones I categorized as 0, 580 said 0, yay, 4 did not. And you can see how you're doing. So you can see, oh wait, so 2 seems to be not doing as well as others. Is that good enough for me? Should I go and change my data set or do something to tweak the model to try to get better accuracy? And that's the art of creating your model. You also can see, so for this image, this is one of my images, you can see all the images, and I can see for that one, which was labeled as a 3, 100% said it was a 3, great. But for this one, 99.1% said it was a 5, others said it looked like a 3. And you can kind of see. You also could, right here and right now, still in here, is I could take another, simulate doing scoring, and take another image, put it up, and see how it would be. So I can do some testing right from here. And at the end of the day, if I think this is good enough, and I'm great, download, and it's going to download to my computer. So I'll have it here on the computer, and what a model really is just basically these. This is some prototext file and the Cafe model right there. That's all at the end of the day the model is. You can open up in an XML reader and do it.
It's XML kind of thing.
And that's what it comes to at the end.
All right.
I'm going to ask a knucklehead question. Is it just images that it does it?
So no, that's a great question. That's a great question. So for this initial release, yes, we're only doing image classification. We are expanding to image recognition. So you have an image of this room, for example, and it says, okay, that's a person, that's a coffee mug, that's a blah. So that's our next use case. But we are planning to expand to language processing and other domains beyond. Okay. But for this first one, This is where we're focusing, and then really a lot of people who do deep learning, this is the first one they focus on, those are the kind of the use cases that we see in computer vision being very popular right now for deep learning.
It doesn't require you to be like a cancer expert. The cell, that's something you're just, okay.
Yeah, you're taking a
Then
bunch of
you're
images.
good.
So
Yeah.
actually one of our a group in the health scientists right now are playing with this tool right now to do that exactly. They have already classified a set of images for tumors, of whether it's benign or cancerous, and they're using it right now as a kind of a test bed to see if they can make that quicker, so that you can use a iPad and or something like that to quickly identify, or at least give an indication of it.
So they do thousands of cells that are healthy, so that they can compare them against the unhealthy.
Yeah, they've labeled unhealthy
labeled.
photos so that then the tool can learn,
Very
has
cool.
some idea. I guess another big application for this vision stuff would be like manufacturing inspection, right? That kind of stuff. So that'd be a lot of money on that, obviously.
Yep. I know that. Yep.
And digital surveillance, so, but you could do also fingerprints, right? That's an image though. That would still be an image. The digital surveillance, checking somebody's face, that's still an image.
Still an image.
So-
And an image means video or image, right?
Mhm.
So,
Yeah.
that's a video is just still.
So this model can do it with videos too, if you.
If you take a video and cut it up into 2 frames.
Yeah.
Yeah,
Yeah.
okay,
That's what-
that makes sense.
One of our customers, Discovery, I have the hardest time remembering, Discovery, but it's, they've done keynotes with Diane Bryant, and we had them speak at several of the iSteps, and that's what they do, is videos that they go through, so you can put, you can enter an actor's name and it can show you their exact scenes or whatever, where were they in this certain movie, and it'll take you right to that spot.
Sure.
Or product placement, right? Like they can detect product
Right.
placement and then
How many
ads
times
based on
did a
this
Coke
movie.
show up?
Yeah, right. So that kind of stuff.
Yeah.
Oh,
Yeah, I
Wow.
mean, retail. I mean, it's the list of categories of where you can. This application is
Amazing.
growing
Yeah.
over time.
I know they're going through SlideShare with something like this and looking for copyrighted photos that people drop into their PowerPoint, and then they feed it to a lawyer to say you can't.
Really? So they
I've
can-
had some takedowns on Slidecasts that are 5 years old, and it's always from a lawyer, and it's like,
They have some.
this needs to go down. I'm like, well, this is public,
Domain.
no, it needs to come down. Yeah,
Okay.
yeah, and that's what it was.
Interesting.
Yeah.
Where they search the web for brand violations. I'm sure
Yeah.
Steve Bunn has this.
Oh, I'm sure that's a big application all over the place. Right?
Sure.
So,
Sure.
So I don't have a demo of the deployment side of it. We're still in the works.
It's
but-
like
but-
because when I think of a software development kit, I think of command lines and stuff. This seems to be more of a work environment, right?
Right.
It is, and it's targeted more at your data scientists that are again creating these algorithms and models, and but we've taken the work out of by using MKL and MKLDNN to optimize the frameworks, and we kind of taken that out of the hands of the data scientists here. So that's kind of one of the improvements.
It's nice, right? And
But once you have a trained model, I mean, you hand it over to the developer to integrate it really with a simple API, and it will run faster.
It's kind of
Intel
a
hardware.
deep learning IDE for data scientists, right? So it's a whole other category than the developers, although they can sometimes, the blurry lines between these things, right? But yeah, I
Would
guess.
that be a great way to coin it? Because everybody, I think, would get it, that it's an abstraction layer if it's an IDE. Would that be something we would want to put out there as how we position it, or a deep learning IDE? Finally, fast, easy,
I've been
simple
saying
way for data
easy,
scientists
flexible
to.
user interface is what I've been kind of calling it. Because when I think of the IDE, I don't think of development, and you want the compiler and everything is part of the environment. I don't know. Maybe I'm reading more into it.
It feels analogous to me for what data scientists
guess
do, but
data
maybe it might
scientists-
mislead some people because it doesn't have some other aspects of it. I don't know. It's something to think about.
Yeah, it is.
Yeah.
I don't know.
Interesting
I'm
idea.
just
Yeah.
trying to